Hello everyone. I'm here to talk to you today about SQL injection. SQL injection is a application level attack that does not rely on any vulnerability within the infrastructure. I've always found that fascinating because it doesn't matter what you do on the infrastructure and how hardened your infrastructure is, the application needs to be exposed, and if it's not secure of these vulnerabilities, then it will be subject to being attacked. This has been a problem for many years. The OWASP team was put together back in 2001 and has been trying to raise awareness among developers of these vulnerabilities and how to address them. SQL injection itself is still one of the top vulnerabilities, even though it's quite simple to prevent. This is just because it's easier to not have to deal with the prevention techniques. You can see it is still number one among the attack techniques as of last year. So the rest of this video will go over what SQL injection is and how to prevent it. So how does SQL injection work? The key to SQL injection is that we allow the user to input variables that will alter the SQL syntax itself. And here you see an example. You see these are variables that the user inputs. By allowing the user to do this, we're allowing him to alter the SQL statements themselves. So now if we go to the web page, this is here. So if the user types in a single quote, which is a perfect way to probe to see if SQL injection is working, and then you put in some garbage in the password, you'll notice we have an error. This error already tells the attacker, I can do SQL injection. They don't see the actual SQL, but here you can see the SQL, and it has the extra quote, which is throwing off everything and causing the syntax error. Now, I'll be back in a bit to show you how you can take advantage of this. So once the attacker knows that he can do SQL injection, the key is how, and a clue is provided by the error itself. You'll see that the error ends with a parenthesis and a quote. So you can see here, this is the problem on the actual SQL itself. So how are we going to go ahead and take advantage of that? Well, you create a condition where that SQL will give you a positive no matter what. And the way you do that is by creating an OR equals 1 equals 1. And you can also finish it off so that the SQL is properly configured. Here's an example. I'll go ahead and try this out. You can put anything as the login and then paste our attack. And now you'll see we successfully logged in as Ann Baker. The reason is the SQL statement works out. The user ID and password, well, this condition doesn't work because there's no such user ID as W with a password of 1. But the OR condition makes the SQL true at this point. And then the rest of this is garbage as well. This doesn't really matter. This just makes it a valid SQL statement. So now you are logged in successfully as Ann Baker. I'll be back to give you some more pointers on exploits. Now that we've successfully logged into the system, let's go ahead and do some SQL injection within the application. So here you see we have an order entry. You put the customer number. We have 4 fields that come back from the customer number lookup. And now here's for illustrative purposes the SQL itself. Now let's go back and manipulate that SQL to give us some more information. Now what we've done is we knew there were 4 fields coming back, so we went ahead and did a union with the user ID password, user ID and password twice. Just make sure we have to make sure it's the same number of columns coming back from the users table where 1 equals 1. This was just to round out the SQL statement and make sure it's a proper SQL formatted SQL statement. Now we have all the users and their MD5 hashed password. Now the password doesn't help us, but the fact that we have an admin user does. And next we will log in as that admin user. Now that we know that there's a valid user called admin, we can log in as that user. And we will use this statement here to do that. Go back to the original login screen. Doesn't matter what we put in the user ID. The point is what we put in the password field. Now you'll see we are logged in as administrator. How do we do that? Well, the initial, again, as before, the initial part of the SQL statement is irrelevant. We just want to close that off. But then we add the or, and then we make it or user ID equals admin, because we know there's an admin user, and then we put rounding out the SQL statement with something that's true, so that we can make this part of the condition successful while this one fails, and that allows us to log it as administrator. Now we have full access to the system. Next, I'm going to go over how we prevent SQL injection. So how do you prevent SQL injection? Well, there are several best practices to perform. First, you should not show the real error when you have a problem. You should log that error to the diagnostic file. So for example here, you'll see that we can still have SQL injection, but we're doing it within a try-catch, and we're logging to a file if we have an error. This allows you to avoid letting the attacker know that there is an attack vector going on available for SQL injection. So that's the first thing. The second thing is to use prepared statements. Prepared statement doesn't allow the SQL to be manipulated by the user's input. Just about all programming languages have this. With PHP, it's something called a PDO package. And here you see an example of it. It's very different syntax, but now the SQL itself, it can't be changed. It's got question marks that are filled in only at execution time. By doing this, you're preventing the user from manipulating the SQL. I'll be back. So now I wanted to show an example of how using prepared statements will prevent SQL injection. So here we have the same form, except it's now been modified to use prepared statements. And we go ahead and put in our SQL. And you'll notice the login still failed, and because the SQL was not changed. The attack that we tried to attempt was all just put into the MD5 hash, and that was not a valid password. So that is the best way to prevent SQL injection, but there's other best practices. For example, on the client side, might as well check for valid input prior to sending it to the backend server. And we have a brief description of example of that as well. And here you go, we filled in the form, and the value is too large. So at this point, it didn't even go back to the server for verification. Aside from not showing the user the error, using prepared statements, and client-side validation of input, there are two other best practices I wanted to point out. First, the use of a database table for authentication to a web application is not a best practice. You should try to find some alternative means, whether it be federated identities or Active Directory authentication, or there are products that provide this service. And then lastly, the web application has access to the database. That user that it uses to log into the database should have restricted access just to the tables that it needs. So it should not have access to any system tables to be able to query it. This is so that if you happen to miss prepared statements somewhere in your application and someone attempts an attack vector, it can't get very far. So this rounds out our SQL injection overview. I hope this has been informative, and I thank you very much.